competing. These 45 teams have been working all year long to design, build, and test these robots. And now this week, they have all converged to the Kennedy Space Center Visitor Complex in Central Florida to compete in the 7th annual NASA Robotic Mining Competition. These robots will start at the far end of the bins where you see them right now, which is simulating that the robot was just dropped there from a lander that landed on another planet. The robot's job is to traverse past an obstacle course of sorts. It's an obstacle field that contains rocks and craters. Once it gets past the rocks and craters, the robot is now allowed to dig or excavate. Once they dig and excavate, they have to carry the regular simulant that they have dug. They have to carry that all the way back through the obstacle course again, and they have to dump it into the hopper on the other side of the bin. We see movement from Auburn's robot. You can see on that camera view, Auburn has chose a wheeled robot in order to drive across this regular simulant. This regular simulant is actually crushed volcanic rock, and it is not easy to drive in. It is not easy to dig in. There you can see this camera view of the students in the control room controlling their robots. I haven't seen any motion from New York University here on the right side. So obviously the students are going to be working feverishly in the control room to see if they can figure out what's going on and how to correct it. If the problem with their robot turns out to be something out here, maybe a wire or a switch or a button, if that's where their problem is, there's nothing they can do about it, because we are simulating that this robot is on another planet. We are not there. We are in a control room, either orbiting that planet or maybe in a control room here on Earth. Auburn is trying to make their way across the obstacle field. We are giving the students, there's a good tight camera shot of the wheels on Auburn's robot. The students that are controlling this robot do not get to see this wonderful camera view that you are seeing right now. They're seeing a much lower quality camera view from behind, which is on the top of the screen here on the left, top left. That's this camera view the students are seeing in the control room. And based on lighting and contrast, they may or may not be able to see really clearly where the rocks and where the craters are. So sometimes the teams may end up getting surprised by the rocks and craters when they fall into them. So looking at these wheels, it looks like they have two speeds, super fast and off. That might be related to their issues. All right, they're making some progress now. Rocking back and forth may actually help them. They turned around. So this robot has a digger on the front, which you can see now. It's a conveyor belt with buckets on it. I like to call that a bucket ladder. I don't know if that's the official term. That's just the term I like. So they had to turn their robot around, and they were successful. Now, once they get their digger past that orange line, they can dig. So right about there, if they want to, they can dig. There they go. You can see the bucket ladder spinning. So this whole conveyor bucket system actually plunges downward in order to dig into the regular simulant. So they have to find the right amount of pushing down. If they push down too hard, it's just going to bind up and get stuck. This Regolith simulant is not soft like sand. It can resist your digging efforts if it's pushed on too hard. Now, it's hard for me to tell from this camera view how much Regolith simulant, if any, is dumping into their hopper. But these students, they can put sensors on their robot if they want that real-time feedback as to tell them how many kilograms of Regolith is in their hopper. There's the student's camera. They're zooming in to see what they can see, to see if they can see that Regolith in their bucket ladder system. So the students in the control room are in complete control of this camera view. They can zoom, pan, tilt. They've obviously zoomed into their robot to get a better look, to see the details they need to see. 4 minutes remain in this competition for Auburn University and New York University. Sadly, I have not seen any motion out of the New York University's robot. But this is the first attempt for New York University. They will get another official.